Hello viewers. Now let's see how we can show that in general for any rectangle drawn inside any right angled triangle, okay, the area of the rectangle cannot exceed half the area of the triangle. Now this is a general case, okay, that anytime we have a rectangle drawn in a right angle triangle, that is in any right angle triangle, okay, now the maximum area of the rectangle will not exceed the area of the what? Triangle. Yes, it's a general, that is, it is a fact, okay. But now let's see how this can be done, how we can prove why, for any rectangle drawn, in a right angle triangle, okay, the maximum area, okay, the rectangle we have will not exceed the area of what? Triangle. We know that the area of triangle is what can be measured as half times base times height, okay. So let's see how this can be proved, okay. Now let's let's set up the problem. The first thing is, let's draw a right angle triangle, okay. Now first, okay, let me say for step one, okay, draw a right angle triangle with legs of side A and B, okay, with legs of side A and B. So we have a right angle triangle. This is a right angle triangle. It is a right angle triangle because it has angle 90 degrees, okay. One of the given angle is what? Angle 90 degrees, okay. And when we talk about a right angle triangle, okay, a right angle triangle will have two legs. So the two legs of this right triangle, okay, are what? Are legs with side A and what? And B, okay, side A and B. So we know that area of the right angle triangle, will be 1/2 of the base times what? Height, okay. Remember, A is the what? A is the base, okay, then B is the what? Is the height in this case. Okay, now step number two. Remember, for any rectangle drawn inside any right angled triangle, the area of the rectangle cannot exceed, okay. Now when we say cannot exceed, so we need to find out, we need to show why the area of rectangle will not exceed the area of what? Of the right angle triangle. So now this time, now let's draw a rectangle, okay, inside this triangle, okay, inside this triangle, and let x and y be the what? The dimensions of the rectangle, okay. So which means I'm going to draw a rectangle, okay. Let me use the same diagram. So I have a rectangle drawn inside the triangle. So remember, for the triangle, the height of the triangle is B. So, and I said this is x, okay, which is the length of the rectangle, and then this is what? Y, which is the what? Which is the width of the rectangle. So we have the height of the right angle triangle. So let me redraw it here. So this is what we have, okay. We have a right angle triangle, okay. We have a right angle triangle, okay. We have a right angle triangle, and then we have a rectangle drawn inside the right angle triangle. So this is x, okay, and then this is what? Y. So like I said, the base of the triangle, okay, The base of the triangle is A. The base of the triangle is A. Why? This is what? X. This is X. Okay, then this is what? This is Y. This is Y. So the height of the triangle is B. So just like what we have here. So in this case, the area of rectangle, okay, area of rectangle. So that means area of the rectangle will now be length times width, and that is what? XY. Remember I said we're going to make X and Y represent the what? The dimension of the rectangle. So we have X and Y, okay? So now, this is the area of the rectangle, and we also have the area of the triangle. So the next step will now be to what? Now, that is, we're now going to find the relationship between the rectangles, that is dimension, okay? How the rectangle's dimension is related to the what? The triangle dimension. That is step 3. Okay, step 3. We're going to say that relating the dimensions of the rectangle, okay, to the dimensions, okay, of the triangle using what we call similar shapes. So if you are going to use similar shapes, so we have another right angle triangle. So the smaller right angle triangle at the top of the, that is at the top of the what? The rectangle, which is inside the what? The larger right angle triangle, okay, will be what? Will be similar to the what? To the larger right angle triangle. Okay, so their corresponding sides, okay, will be what? That is the corresponding side of the smaller triangle and the larger triangle will be related by, that is using similar shape. That is using similar shape. So in this case, the shape is what? Triangle. The corresponding sides, the corresponding sides, okay, of the smaller right angle triangle and the larger right angle triangle are related by, so in this case, that is what I mean in this case, that is relating the dimensions of the rectangle to that of the what? The right angle triangle. That means X, that is the dimension of the rectangle, which is the X and Y, will be related to A and B. All right, so we're going to use similar shape. Okay, that's similar shape. The similar shape is the what? The triangle. Okay, so the corresponding side of the what? Smaller right angle triangle. Okay, or let me just put it this way so that we don't get confused. Smaller triangle, okay, and the larger triangle, okay, and the larger triangle are related by, so that will be Y over X equals to B over A. So now let's obtain the expression for Y from here. So we are going to say that Y equals to B over AX. Now let me call this equation 3. Okay, so because we have this to be what? Equation 1. We have this to be equation 1. And then this is what? Equation 2. Okay, so we have, this is the relationship between Y and X in terms of, so now we have Y equals to B over A times X. So having done this, now the next thing is now to find the maximum area of the what? Of the rectangle. So this time the area of the rectangle, or the, yes, the area of the rectangle will now be, that is, okay, let's do it this way. Now let's substitute, now before we find out the that the rectangle will be what? Will be equal to the right, will be equal to the right angle triangle in terms of, That's after relating the dimensions of the rectangle to the what dimensions of the triangle using similar shape. Okay, now then the connectivity again is that in order for us to calculate or to find the maximum area of the rectangle, okay, so that means that the area of the rectangle, okay, will be related to the area of the what of the right angle triangle. Now I know we have here that 1/2, that is half of AB, is the what is area of right angle triangle, and this is the area of the what the rectangle. So substituting, let's substitute for y, okay, for y in equation 2. In equation 2 we have equation 2 to be what, we have area of rectangle to be equals to x. Now y is now what, b over a times x, so that the area of the rectangle can now be b over a times x square, b over a times x square. Okay, that's b over a times x square. Now to be able to show this down, our step 4, okay, to calculate the maximum area of the rectangle. In order to calculate the maximum area of the rectangle, now this is what we're going to do. Okay, now to calculate the maximum area of the rectangle, so what we do is, now when we look at this figure, okay, now let's say now let's say let's consider that the top right corner of the rectangle, okay, the point, that's the point where the top right corner of the rectangle touches the hypotenuse. Let's say it has a coordinate of y. Okay, now what I mean is that let's consider the point, okay, where the top right corner of the rectangle, okay, of the rectangle touches the hypotenuse. You know, the hypotenuse is the longest side in a right angle triangle. Okay, so which means that the equation of the hypotenuse, because that point lies on the what hypotenuse, that is, this point lies on the hypotenuse. So let's consider the point where the top right corner of the rectangle touches the hypotenuse, and then let's say the coordinates at that point is x and y. So then we have that the equation of hypotenuse, okay, the equation of hypotenuse will now be y equals to, you know, we know that when it comes to what we call slope point, that slope intercept form, okay, slope intercept form. So we have y equals to negative b over a, because when we look at the slope of this line, okay, now let's say this is the x-axis, this is the y-axis, so the slope will be what, negative, so that will be negative b over ax plus b. Okay, now this is the equation of the what of the hypotenuse, because the coordinate xy, okay, is a point which lies on the what, on the hypotenuse, just like what we have here. Okay, so I'm just trying to manage the space. So in this case, we know that now we know that y is equals to b over what, ax. So I'm going to put that here. So we have b over ax equals to negative b over ax plus b. So we have to rearrange this. So when this is brought to the left hand side, okay, we're going to have 2b over ax equals to b. Now we can cancel b by, when we divide this by b will be divided by both sides, so that this will be, so we can have 2 x over a equals to 1. Okay, so now let's make x the subject of the formula. So from here, x will be equals to a over 2. X will be equals to a over 2. Now, let's check what we have here. So, I said here that area of rectangle is b over a times x squared. So I'm going to bring that here. Okay, so by bringing it here, so now let's see what comes out of that. So we have that. So this is a. Now we can then say substitute for x in which equation? Now this is equation 4. I beg your pardon. So we have equation 4. So in equation 4, so we have area of the rectangle to be, we have b over a. So x is now what? A over 2. So we raise that to the power of 2. So that this will be b over a times a squared over 2. So a will divide what? A. So we are going to have area, okay? Area to be, area will be 1/2 multiplied by BA, that's multiplied by BA, okay? Now, that's 1/2 multiplied by BA. So when we know that, now we have b over a times x squared, and x squared is what? X is a over b, a over 2. So we have a over 2 raised to the power of 2, okay? And that'll be a squared over 4, beg your pardon, a squared over 4. So when a cancels a, okay, we'll be left with what? A, okay? So this will be 1/4 times AB, okay? So which means the area, okay, the maximum area of the rectangle, okay, which is what we have as, so this is max, okay, will be 1/4 AB. So when compared with the area of triangle, okay, now compare with area of triangle, and we know that area of triangle is 1/2 of that is half of AB. Am I right? That is base times height. Then here we have the maximum area of the rectangle to be what? 1/4 AB. Remember I said to calculate the maximum area of the rectangle, let's consider the point where the top right corner of the rectangle touches the hypotenuse. So that means that the largest possible value for x will be a. So that means if x is equals to a, then y will be equals to b. Am I communicating? That is, what I'm saying is that now here we have the dimensions for area for triangle to be equal to the dimension for what? For rectangle. And that's why I said the area of the rectangle now becomes the area of the triangle. But in this case, the area of the rectangle is not equal to the area of the triangle. That is, we want to find out why the area of the rectangle, okay, will not exceed the area of the what? Of the triangle, even when the dimension of the triangle, okay, are the same with the dimension of the what? Of the rectangle. So which means when they say calculate the maximum, or show that the maximum area does not exceed the area of triangle, what that means is that the largest possible value for x, okay, for x will be what? A. That is if, and that for b, I mean for y will be what? Will be b. So if x is equals to b, okay, so when compared with, so we can see here that the largest, the maximum area of rectangle does not exceed the area of triangle. And now the reason, okay, the reason is that the largest possible value for x is a, and for b, for y, okay, is b. That is, x will be equals to, that is, x will be equals to a, and y will be equals to b. So this is the result. We have been able to prove Okay, this is proven. Okay, this is proven. 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 But this one is just the reason why we have the area of the triangle to be equals to that's the area of the rectangle to now become the area of the what of the triangle, not to be equal to the area of the what triangle. I want you to get my point. Now, when we are when it comes to how to calculate the maximum area of the rectangle, now we must be very careful. That is to calculate the maximum area of the rectangle, and because the question reads the area of the rectangle cannot exceed half the area of the wall, cannot exceed half the area of the triangle. So what we have here is one half of that's half of area of triangle is equals to area of rectangle, and it will not exceed this. And what is area of triangle? Area of triangle is what? Half times base times height. So if I put that here, it will be 1/2 times 1/2, and that will be equals to, that's half times half, that will be equals to 1/4. And that is what we have here, 1/4 AB. Okay, so which means the area of the triangle times 1/2 will be equals to the area of the rectangle, will be equals to the area of the rectangle. So let me write that here. So that means that 1/2, that is 1/2 times area of triangle is equals to area of area of what? Rectangle. Okay, and we know that area of triangle is 1/2 AB, and that's what we have. Okay, I just cleaned that. So okay, so we have 1/2 AB. Okay, now, and I explained why after we substitute we got 1/4 times AB. So which means when the dimension for triangle is now the same with the dimension for rectangle, but the area will not be equal, because the maximum area for the rectangle cannot exceed the area of the word triangle. So in this case, this will be 1/2 times 1/2 AB, and that is 1/4, which is 1/4 AB. So which means the maximum area of rectangle does not exceed the area of what? Triangle. So this is very important. This is very important, and we just prove why. So this does not exceed. Okay, so this is the area of the rectangle, and we have the area of the what? Of the triangle. The noblest pleasure is the joy of understanding. Bye bye.